Welcome to the Contagious Code podcast, where we dive deep into code, learn practical skills, celebrate the beauty of engineering, and eliminate imposter syndrome.
I am Tejas Kumar, and I've been building on the web for over 20 years at places like Vercel, Spotify, Zeta, and more. Today, my guest is Kyle Corbitt. Kyle is the founder and CEO of OpenPipe. OpenPipe is a web-based service that helps you fine-tune a large language model for your specific case. So you could take a model like Mistral 7B, Mixtral 8X22B, Llama 3.1, or whatever it may be, and fine-tune it for your specific use case. You do this by collecting prompt and response pairs, a lot of them, and the responses could be generated by a more expensive, maybe closed source model like Claude or OpenAI's GPT-4. And when you have enough of these, you upload them to OpenPipe. In fact, OpenPipe gives you a drop-in replacement for the OpenAI API, where it will first, actually in parallel, send the request to OpenPipe and to OpenAI, and it serves as a logger. In any case, you collect all your prompts, all your responses, pick a base model, so Mistral 7B or something small, and OpenPipe does the rest. Just at the click of a button, it will create you your own specialized fine-tuned model against which you can run evals. That is, you can test them with prompts, and if they do the job, congratulations, you have a cheaper, smaller, more specialized model for you. Full disclosure, I'm an investor in OpenPipe, but it truly is a remarkable product. And in our discussion today, Kyle and I go into detail about how it's built, how it works, and how machine learning fine-tuning works in general. A lot of us maybe are AI engineers or full stack or web engineers, but we don't really have a background in machine learning and or Python. And so in our discussion today, we go deep in that area, literally asking Kyle, hey, if I wanted to fine-tune something without OpenPipe, how do I do it? If I wanted to train a model, how do I do it? And Kyle is a aficionado. He's a real master at this, and he explains it in a lot of great detail. We also talk about function calling, meaning how do large language models, recognize when to call a function that a user supplies? How do they recognize the end of their abilities and then recognize like I need to call this function? And the cool thing is it's not actually as complex as you think. It's just training. And so we dive into the details of all of this. It truly was an insightful discussion, and I hope you enjoyed as much as I did. Now, I'd like to offer this to everybody at no cost because this is very much separate to my day job. The way we can do that is through partners and sponsors. Let's take a moment to acknowledge them. The Contagious Code podcast is sponsored by Code Crafters. Code Crafters is a way of learning that is very close to my way of teaching, which is they take tools we use every day as developers, Git, Redis, Docker, whatever, and they have you re-implement those tools from scratch in a language that you choose, like JavaScript or Python, whatever. And by doing this, you get better at your language, that is JavaScript, Python, Rust, whatever, and you get better at the tool, like Git, Redis, or Docker, because you understand it, because you build it. They walk you through it, and in the end, you create a clone of this in a language that you want, and so you level up at both. It's really great. They have a generous free tier, but should you start paying, you can get 40% off if you use the link in the show notes. That's tej.as/codecrafters. Thanks for sticking around, and now for my discussion with Kyle Corbitt. Kyle Corbitt, absolute pleasure having you on the Contagious Code podcast. As a user of OpenPipe myself, I'd like to think even an early adopter maybe. So excited to have you on this episode.
Awesome. Yes, extremely excited to be here.
Let's get started talking about OpenPipe, and I want to dive into sort of where it came from. I mean, I recognize it now as a useful tool to bring down my own LLM costs. But I mean, to have the idea and then start a company, by the time I only started to feel the pain, must have taken some serious like being ahead of the curve. So I'd love to talk about the origin story there. But before we do that, maybe let's talk about you a little bit as the founder and CEO. Particularly, let's just do a quick introduction to the listeners, who you are, where you come from, and then we'll get into OpenPipe.
Sure. Yeah. Very excited to be here. And thanks for the question. So I, let's see. So graduated in computer science. I think on the, there's definitely multiple threads that came together to starting this company. And I think that's true for probably any founder. Come from a very entrepreneurial background. My dad was actually also like a software entrepreneur. I grew up in the Seattle area because he actually ended up coming here and joining Microsoft later. So, that's sort of, I guess, part of my family history. Then as far as the specifics that came to sort of like brought me to the place I am with OpenPipe, Graduated, I was really excited actually about machine learning, and this was about 10 years ago when I graduated college. And looked very deeply into both, like, could I start a startup in this space because I already knew I wanted to be a founder, or even I actually applied to a few graduate programs and got into them, and considered going that route as well. But ultimately, at that time, and again, this was 10 years ago, it was not obvious that there were any opportunities for startups in the machine learning space. And I think that's sort of been borne out if we look at sort of the companies from that era. The companies that were really taking advantage of machine learning, even though it was very exciting at the time, were all big tech. That was really the only place it was providing value in the short term. And so I was looking for that, couldn't find it, ended up starting a completely unrelated company, which was we actually were recording digital histories of elderly people and sharing it with their families. That's an unrelated story. But I was keeping my eye on the machine learning space because I was very excited about it, and I'd done like a fair amount of research actually, even just as part of the undergrad. And so anyway, my journey went in other directions. I worked at Google for a while. Actually went to Y Combinator. Worked at Y Combinator for about 4 years, running the startup school program there. So doing lots of actually founder-facing content and interviews on the other side of this as well. But sometime around 2020, it started becoming very obvious that there was the world was changing a lot, and specifically the world around AI was changing a lot. And there were a couple of different really key breakthroughs that made ultimately, the whole Gen AI space, but like specifically what we're doing at OpenPipe possible. And so the first one was, it was a little bit earlier than that. Like the 2018, 2019 timeframe, there became this, there was the development of this idea of like pre-training versus fine-tuning. Because prior to that, deep learning was already working well, but the way everyone was using it was you had your task and you had to have millions of examples for your specific task, and you would always just train a model from scratch. That was kind of like the industry standard. And of course, the only way to do that is if you already have huge scale, which is why the big companies were doing it. And then starting, there was a paper ULM fit, and then also sort of like BERT really popularized this idea. But there was this idea that you could actually just pre-train on like text that is completely unrelated to what you're doing and build a model that was really, really smart in general, and then later go ahead and apply that model just to your specific application. And that was a real aha moment for me because it became it became clear that like, okay, well, this is going to make it way more applicable to a whole new size and demographic of companies than were using it before, because instead of needing millions of examples, maybe you can use tens of thousands or hundreds of thousands of examples in those earlier models. And of course, since then, that number has continued coming down. So we're watching that really closely. And then, of course, the other thing that happened a few years later, 2022, and then, of course, really exploding in 2023, was this idea of like, you don't need any training at all, right? And that's really what the main breakthrough has been with GPT 3.5, GPT 4, is you can actually get something to market without doing any training at all. You don't need any data set at all. You just need to kind of like describe your task, and it works. And so that actually is really complementary with sort of this idea of pre-training and fine-tuning, because now there's this flow that works really well where you can go from, okay, I'm pre-product market fit, I don't have anything in the market, I'm just playing around, in which case you can use prompting, you can get to the point where it's like, okay, I have something working, and then it just plays really nicely because as you start getting more data, as you start having more users, and as those costs goes up with those really huge models, then you can sort of seamlessly transition over to, okay, now I'm fine-tuning a model, and as you get more data, you can actually move smaller and smaller models and make them more and more specialized on your thing. So that it's sort of like this continuum, whereas before there was this giant cliff of like, hey, you have to have these millions of examples before you can do anything at all. So anyway, we saw that happening. I recruited my brother. Actually, my co-founder is my little brother. And, we basically got him excited about this as well, and the way the world was going. And we started the company about a year ago, and our whole goal is to just help people make that transition as easily and smoothly as possible.
Wow. Thank you for that history. That's okay. So it started with a background in, you mentioned computer science. I have to assume this is machine learning and keeping an eye on machine learning. Yes?
Totally. Yes.
Okay. Good. And you mentioned back then there was only, what was it? You had to train a model from scratch. Did that mean you needed an entire, like a large corpus of data, and then you run it through some type of deep learning algorithm, and eventually you do gradient descent, and your outputs match closer to what you want anyway, with a higher degree of confidence? Is that what I understand correctly by training from scratch?
Yeah, exactly. So you would have, effectively, and this was pre-Gen AI, so usually the types of tasks people were doing with this are, I think the classic ones are classification, right? So it's like, hey, I have an image, I want to know, is this a cat or not? And then things also like, what they call named entity recognition, which is basically just like extracting data from a document and saying like, hey, give me all the person names that are in this document, because maybe you want to match that against a list of people or something. Those are two of like the big classical tasks. And then there's also sort of regression, which is like, hey, I'm trying to guess, how likely, basically like how likely is it that this will match this other thing. Those were sort of like the real classical bread and butter machine learning tasks that people are doing. And yes, like you were saying, you just have, you'd have like 10 million pictures, and like 5,000 of them will have cats, and all the rest won't. And then you have to train the model on that entire thing. And the important thing is you were basically doing that from scratch. You were starting from zero with just a completely fresh model. And so that's why you needed that much data for it to figure out what the heck was going on in the world.
Awesome. Yeah, thanks. We're just trying to make it very, very accessible, these terms to listeners. So I appreciate going into a little bit more detail there. So you mentioned there was this dissonance between pre-training and fine-tuning, almost like there's trade-offs. But as far as I know, I don't quite understand the dissonance there, because a fine-tuned model to me is one that you take a pre-trained model and you fine-tune it. No, so they seem almost complementary, because the basis of fine-tuning is a pre-trained model.
Okay,
Sorry.
You're exactly right, and maybe it's possible I was unclear in the way I described that. So thanks for calling it out. No, not that there's a dissonance. It was more just people realized that you could split this up into two separate steps, and the data you needed for each step could be different, because previously there was no distinction. Just everything was pre-training, or you could say the other way, everything was fine-tuning. The point is, before, all of the data that you would give to the model was task-specific. And so now, in this new paradigm, you can split it up, right? You can have data that's completely unrelated to your task and use that for pre-training. And the magic is, the reason why this is a good idea is because there's way more data in the world that's not related to your task than data that is related to your task. So if you can find a way to use that data effectively, which is what pre-training is, then you can be, you just need a lot less data that is task specific.
Awesome. Perfect. Yeah. Okay. So I love this. So you start with a large language model, if we speak today's colloquial language, or you start with a very broad model, and then over time you accumulate data that is specific to your task. And as a way of even reducing cost, you just create like a smaller specialized model. So you go from LLM to SSM, small specialized model. We're inventing that term if it doesn't exist.
It's like a small language model. Usually the architectures we're using right now are still language models. It's just at smaller scales. There's actually, and this is a complete tangent we don't have to go down, but I do think there's a lot of potential in actually moving to new architectures. I think large language models are what most people are going to start with, because basically they're the most general purpose. They have the best pre-trained models available right now. But there are other types of models and other shapes of models that, like, for a specific task, like if all you're doing is classification, which is what a lot of people are doing here, like that's actually what been a tangent on the tangent. That's something I've learned that's been fascinating to me as we build this company, is like the number of people who just have pure classification tasks out there that, like, you don't actually need an LLM to solve, but people are using LLMs anyway, just because the barrier to entry is so low. It's so easy to get started using them for that. Anyway, if that is what your task shape is, then eventually maybe you want to move off an LLM entirely, because there are other model architectures that are more efficient for that kind of task. And so you can get away with a much smaller, much faster, much cheaper model if you go that specialized route. We don't do that right now. It's something like we are investigating, and we like definitely are planning on supporting in the future. But anyway, I think even going to smaller language models, you still get a huge benefit.
This is so cool. And I definitely want to go down that tangent if and when we have the time after our planned discussion. By planned discussion, the discussion is mainly around OpenPipe, because this is technology that I use, this is technology that I invest in, this is technology that benefits me greatly, frankly. So for those who maybe don't know, my website has a podcast search. So we have tons and tons of hours now of content, and each episode being 2 hours, it's a haystack. And sometimes people want that needle, and we use a RAG technique on GPT-4o, or a custom fine-tune that we get from OpenPipe to bring down costs. And so thank you first for the product. And second, let's dive into the product, right? Let's talk about OpenPipe. You've already sort of told us the origin story, but I'd like to talk about, like, the work that OpenPipe automates away. Meaning, if I was to fine tune a model, if I started with a large language model, as we talked about, and all I need is a very small search across my podcast transcripts, maybe not even search, but I wanted to generate data about my podcast transcript, right? And I want to do this maybe with a fine-tuned Mistral 7B because it's open source and cheaper, and I can sort of host it where I want. What's the process there? And maybe we can do it like this. I tell you the process, and you tell me what I missed. This is a great way. I do this with guests.
Sounds good. Let's do it.
Okay, so what I would do is get a ton of prompt response pairs, maybe 100, right? And prompts are user searches. They go like, tell me about, resource hints. And then, GPT-4o gives me output. And this is creating the synthetic data that I need for my fine tune. And so I get a bunch of this. And this is where OpenPipe has this logging feature, which, by the way, that SDK. So OpenPipe gives you, I'm talking more about OpenPipe than you. Listeners don't like it when I talk more than guests.
I'll tell you if I have anything to add, but yeah.
Good. So OpenPipe gives you this amazing drop-in replacement SDK for the OpenAI SDK. That is so cool. I just changed the import and everything works. That's fantastic. And so what it'll do is it sends my user's requests first to OpenPipe, then forwards that to OpenAI, and OpenPipe captures this. It captures the prompt, it captures the response when it comes back from OpenAI, and stores it. So it's like logging. And then from the logs, I can cherry pick. I'm like, oh, that was a good one. That was a good one. That was a good one. So I collect like a bunch of the really good prompt response pairs, and I use it. And I'm intentionally being sort of shallow here in this next step. And I use it to then continue fine tuning my cheaper specialized model. Is that accurate so far?
Yeah, I mean, there's like a couple of nuances I'd throw in there. One is that like we actually put a lot of effort into the SDKs because we didn't want a lot of users, and it depends on the use case. I suspect actually you fall in this category are very latency sensitive, and we didn't want to make there be any downsides to using our SDK. So it's actually not that you send, when you're using it for this logging feature, it's not that you send it to us and we forward it to OpenAI. You actually still send the request directly to OpenAI, you get it back, and then in the background, our SDK just reports it asynchronously to our server to just avoid any kind of latency issue there. But let's see. I mean, otherwise, yeah, that's broadly right. A few other things that are steps, sort of optional steps, and I think what you described is sort of like the basic flow where most people get started. A lot of folks, as they are looking to improve quality, there's other functionality they can use. So, you mentioned going through and picking the right responses. If you're only doing a few dozen or a few hundred responses, that could work. We have a lot of users who, especially if you have a complex task that has a lot of nuance to it, you really want a few thousand examples or maybe even a few 10,000s of examples. And at that point, manually going through and clicking them is not fun, and we don't think you should have to spend your time on that. So we have, for example, an LLM filtering feature where it can actually take from your request logs, you can describe, hey, this is what a good request looks like, and we'll actually use an LLM to go through on a log by log basis and filter out the ones that are like, oh, okay, this matches all the criteria that the person asked for. And we find that in practice that actually improves dataset quality pretty significantly. We have a lot of users who are getting great value out of that. And then another one is actually like a relabeling feature that's built in on the product side. So let's say that you want to use GPT-4o, but latency is really important to you. And this is actually something that is a common, I'd say the two biggest reasons people use us are cost and latency. And so very often you have an experience you want to keep really snappy, and even GPT-4o is still substantially slower than, say, a GPT 3.5 or one of the fine-tuned models you'll get through OpenPipe. And so what users will do sometimes is in production, they'll serve using, say, GPT 3.5 just because they really care about that latency. And then within the OpenPipe platform, once they've selected, hey, these are the inputs we care about, we have like an automatic relabeling filter. So at that point, before you train your model, you can relabel all of those data points that you're going to use to train it using GPT-4. So instead of just training directly on the responses you got from GPT 3.5, which maybe are not super high quality necessarily, you can regenerate basically the synthetic data with the exact same inputs that you got from production. And the only difference being now the outputs, instead of being from GPT 3.5, they're going to be from GPT 4. You're going to have a higher quality data set, and ultimately your fine-tuned model is going to perform much better.
That's incredible. And so just to clarify for the listeners, relabeling just means rewrite the output, right?
Yes, exactly. So yes, so you're keeping the exact same input, and then you're just sending it to a model and getting a new output.
That's incredible. So with OpenPipe, you sort of use AI to do more AI. I mean, what I'm hearing is you can curate your data set for your fine tune, or rather you can offload the curation of this to a large language model, which kind of blows my mind. That is so cool. Okay, I love that. I haven't really used that yet, but I look forward to doing it. Let's talk a little bit about developer experience, because this decision to have a SDK that is a drop-in replacement for the OpenAI one, how did you all arrive at this conclusion? Was it just thinking forward to what would we expect as developers? And then I guess the choice for OpenAI's SDK as opposed to, I don't know, something else like the Vercel AI SDK, Anthropic, etc. Because different vendors have, is it just virtue of OpenAI being the most used one, therefore we go with that? Or can we talk a little bit about the decision-making process there?
Yeah, great question. So, I mean, the reason we went with OpenAI's SDK directly is because we found that was just, it's what gets the highest usage. And that was especially true a year ago. I mean, a year ago, the Vercel AI SDK didn't even exist. So that did get the most usage. We actually do have a replacement for Anthropic's SDK as well at this point, which we developed just a couple months ago. And I expect we'll have more shims or integrations in the future. I think like Vercel's AI SDK is really slick. I actually think they may have the ability to sort of like add plugins. We may not even need a wrapper. We could potentially just like integrate with it, and then you could use their SDK and add OpenPipe. I'm not sure about that. We haven't actually built that integration yet. So I do think like our goal generally is basically to be as non-disruptive to your existing flow as possible, right? That's the guiding principle. So that's why we went with OpenAI. I think the reason we sort of had that insight is because like my co-founder, my brother, and I both had built a bunch of tools on OpenAI. We were very excited about this. And so, like, for example, I built this translation app, which I actually sold to an existing incumbent right before starting this company for document translation, right? And it was like, hey, if you need to do formal document translation, say you're applying for a passport or something like that, and you need documentation translated into new language, basically just like upload the file. And then anyway, the scope of this is a little bit out, but the point is it was like one of the earliest apps that I saw like that actually launched on top of, at the time, GPT 3.5 API. And then my brother at the same time was building another, basically like a Reddit scraper that would scrape it and find, according to your specific requirements, like posts that match what you're looking for, using, again, OpenAI's SDK. So I think we have a lot of empathy for the developer because we've been just playing around with this for a long time. And so I think that drove a lot of our early decision making around the shape of the product, is like, what would be helpful to us as we're building these things, like what is what's going to be the best flow. Honestly, like that is where I see the most value in what we build, and on where I think there's the most help, because you can fine tune your own models, right? There's like open source libraries, there's tutorials you can find on Medium or whatever on how to do this. And that's totally fine. And like, if people want to go in that direction, like, I think that's awesome. But like, it's just, the issue is the workflow, right? It's like getting the data in the right format, getting the data in the right place, being able to like visualize and figure out, hey, is my model doing any good? Like, all those workflow steps are super high friction if you just kind of like go out and do it yourself. And with OpenPipe, you can go through all of that with like an hour of work, and you get a nice dashboard, and you see, hey, this is how my fine-tuned model is performing. And oh, by the way, it's also deployed for me. Like, I just have to hit this endpoint with my existing SDK, and it's completely OpenAI compatible. I think that's like, honestly, like, I mean, it's just, everybody's got limited time, right? Like, you don't want to have to spend a month going and figuring out the Python dependencies, and then like becoming an expert in hyperparameter tuning. Like, you just want to like build your app and have it work well.
Yeah, no, for sure. And this is exactly why I use OpenPipe. In fact, you said it it takes a certain amount of time. Indeed, with OpenPipe, for me, within an hour, I was already collecting data, and then like within 24 hours, I had enough to just run a fine tune and see. And I think that the pricing model, we'll get to that, is also so intelligent because it's for the most part pretty low cost, and you pay for fine tunes. As far as I know. To be fair, I haven't used it. You guys ship way too fast, which is great. But at last I checked, the payment is mostly based on fine tune capacity, which I think is so cool. Okay,
No, that's
awesome. Thank you for that. This echoes sort of the episode we did with Guillermo Rausch, CEO of Vercel, who mentioned, something that he values highly, and the reason Vercel is able to create such quality products is because they themselves use it. And you mentioned developer empathy. That is core to Vercel, and I'm happy to see that that's core to OpenPipe. Okay, so if we go along this now fine-tuning process, so we've got the sort of logging step. We have a bunch of stuff in OpenPipe. We let our LLM relabel it if we need to, and then curate like a nice training data set. In OpenPipe, the next step is to pick a base model, right? So you pick like Mistral 7B, and again, I may be dated since y'all ship a lot. You pick a base model. You pick a data set and you say go, and you pay, and it starts fine tuning. What happens behind the scenes there? And I'm asking on behalf of listeners who are wondering what the frictionful work is that OpenPipe saves them from. So can we speak to that? Like if somebody was to, I don't know, like read one of these Medium articles, start a little Jupyter notebook, pip install transformers, do all of that. What does OpenPipe do? What is the heavy lifting that it does here?
Yeah, great question. So aside from sort of the workflow pieces of like having this all in one place, and like you said, you can get started, you can actually like be fine tuning in an hour if you've got a data set, or within a few days if you're waiting for it to collect. I think an interesting position we're in is because we now have thousands of users that have fine tuned thousands of models. And we'll actually get in a moment to sort of the evaluation side, which I think is also really important. But the point is you can define on platform your own evaluation criteria for these models. We're in like a really fantastic position where we are actually pushing the state of the art on the actual hyperparameters that you use. So when you're fine tuning a model, there's a few different things you choose. Like you alluded to right now, obviously you choose a specific base model. So that is kind of the unspecialized model that you're going to start with as you're creating your fine tune. But then beyond that, there's a lot of other knobs you have to tweak. So these are things like setting the learning rate, setting the number of epochs, setting the learning rate schedule, the optimizer. These are all different things that are tweakable and can have quite a large impact on performance, for better or for worse, depending on how well aligned you are. And the state of the art up until this point, and what most people recommend when you are doing, say, if you're just running this yourself in a Jupyter notebook, is that you do hyperparameter sweeps, it's called. And what that means is basically just like you try a bunch of different values, and then you see which one works. But the problem with doing that is there's like a lot of these things, like a lot of these different values you potentially can tweak. And so, of course, it's multiplicative, right? Because if you're trying 6 values for the learning rate and you're trying 2 different schedulers, and then you're also like trying, 4 different like numbers of epochs, well, now you're doing 100 training runs or whatever. So you have to be a little bit smarter about like which combinations you're going to try out. And so really the state of art is typically like, hey, try a few different combinations, see which one looks best, and then go to that spot, kind of in the whole hyperparameter space and, try a few more in that area. And it's kind of a mess. It takes a long time and it can get quite expensive. So since we do have thousands of fine-tuned models and thousands of, perhaps as importantly or more importantly, evaluations that are user-defined on platform, we can do a really fantastic job. And this is actually like where we have like most of our research efforts right now on getting to the right hyperparameters based on your specific data set quality, or your data set metadata that we collect. And so we're, I think we can, there's a lot more room to push there, and we've got some like really exciting stuff that we haven't actually shipped yet. But even where we're at right now, like I am quite confident that the model you're going to get from fine-tuning on OpenPipe is going to be much stronger than if you're just doing it yourself, because behind the scenes, these are the things we're optimizing, because we've seen thousands of other models, and we can start making trends about, hey, for this specific data set size, for these inputs and outputs, for this base model, these are the good heuristics that basically for setting these values.
Yeah. I have a really silly question here, which the audience tends to appreciate. Why are they called hyperparameters? I mean, they're just parameters, no? Learning rate. They're almost like inputs to a function, which sometimes are just called parameters. What makes them hyper?
Yeah, okay, that's totally fair. The reason is somewhat historical, but it's basically because traditionally, and really to this day, like parameter in machine learning, it refers to the actual literal weights. So you've got like a 7 billion parameter model, right? Mistral 7B has 7 billion parameters. And then hyperparameters are kind of just like abstracted one level above that, right? These are things that like affect the behavior or the training behavior of the model, but we can't just call them parameters because we already use that word for the weights of the model itself.
Right. It's a reserved word. This makes so much sense. Great. Yeah, so exactly what you mentioned. And I love that OpenPipe is sort of inferring the ideal hyperparameterization for fine-tuning, because I've actually fine-tuned models myself in a Jupyter notebook on my Apple Silicon just to try. Yeah, and this is where I struggled, right? Because I was like, I don't know what learning rate to set. I don't know. Do I go with low-ranking adaptations and PEFT, so parameter efficient fine-tuning? Like, yes, no, I don't. And like you said, there's so many permutations you could do, and each learning bout costs an enormous amount of time. Like, I'm not here on like the latest NVIDIA H100s. I'm on Apple Silicon, and so even on a tiny data set, I lose an hour to training with the hyperparameters frozen. And I don't know if they're good or not until I then get a fine tune and evaluate it. And so if I can have someone say, hey, these hyperparameters, just they work. 9 out of 10 times they work well. Let's start with that, I think would be key. What are some methods, some protocols people can use, listeners can use, to sort of guess or land on the right? Is there such a thing, or is it more highly dependent on data set, hardware? I feel like it's impossible to predict, but maybe you know something here.
Yeah, I mean, I think it's extremely hard to give general advice here. I can tell you some knots that we've learned, which I don't know how helpful this is. So in traditional sort of like if you read a lot of information out there on the internet about, hey, how do I know if my model's working well or not? One of the sort of like proxy metrics they will often tell you to watch is, as you're training, there's this concept of loss. And loss just means, like, as the model is going through this specific text, how confused is it effectively, like, or how good is it at predicting each word, right? So the higher the loss is, basically the worse it is at predicting the word. And so as you're training, usually what you're seeing on the data you're training on is that your loss is going down and down and down, because the longer you train, the better the model, assuming everything's going right, the better the model's getting at predicting this. Now, what's very traditional, and what we do as well, is you split your data set into at least a couple of different pieces. Sometimes, in fact, often and we actually split into 3 different pieces, but the way it works is you have one set, and this is usually the majority of your data, which you're using actually for training. This is like what you're actually showing to the model and saying, like, hey, figure out how to produce outputs that are more like this, right? And then you'll have, in our case, we have 2 different splits. We have one that's like totally not visible or used at all in the training, and then a small piece that's the validation set, or the test set that is used in training, and kind of almost in real time as you're training, you're also like checking, hey, what's the loss on this other set, and seeing if it looks like it's going in the right direction, right? So traditionally, the advice was, okay, you're watching this, how as your training is progressing, hopefully on the data you're training on, the loss just keeps going down, 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 because the model's learning to do it really well. But sometimes the behavior you see is, as you are, so on the piece that you reserve, that you're not using for training, you're just doing to check that it all looks good, usually what you'll see is it starts also just like the training data. Okay, loss is going down, 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 down. But then you have an interesting point, which is, it's very normal to train for multiple epochs. And an epoch just means, hey, I'm going to show all my training data to the model multiple times, right? I'll show it all to the model once, and then I'm going to continue training and just like repeat it and show it all to the model again. And the reason you do this is because you have limited data, and the model doesn't like figure everything out the first time it sees it. So just showing it more times can kind of help it. Now, the problem you run into if you show it too many times is there's this concept of overfitting. And overfitting just means it like memorizes basically the inputs it was trained on, and it gets so specialized on those exact specific inputs that if you have some other input that's like similar and the model should do well on it, like maybe it'll just do really poorly because like the only thing the model knows how to do is like these exact inputs that it was trained on. So anyway, all this like so you want to do often more than one epoch because the model will keep learning more from the data. But if you do too many epochs, you run into this overfitting thing where it's just purely memorize this and it's not going to be able to do anything outside of like literally these exact examples. Now, the way traditionally you could detect, hey, my model is overfitting and I should, I should stop training at this point. I shouldn't keep going because it's just going to make the model worse on anything that's not literally this exact data, is you would watch this loss curve for your test set. So you would watch how, okay, it goes down, 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 and then at some point it's going to flatten out for a while, and then as you do more epochs, as you keep showing the training data, then the loss curve starts going back up, right? And classically, you detect that point where it's going back up, you're like, okay, it's overfitting because now, even though the model's still getting better on the test data, it's getting worse, or on the training data, it's getting worse on this test data, which means that, you're overfitting. That's the classical thing that makes intuitive sense. What we found is that for LLM specifically, for text generation, it's just wrong. Like you can keep training for long after your test loss keeps increasing, and if you actually take the final model and you run your downstream validations on it, and you figure out, you run your downstream validations and like on the actual model outputs, say like, hey, are these outputs better or worse on the test set? They're better. Like if you're running LLM as judge, or if you're like running a classification task and you have like a golden data set to compare to or something, like even though the loss curve is going up, like the actual outputs are still better. This is not, I don't know why this happens. Like this is just purely an empirical result that like if you actually take that model, it's going to do better. Now there's a limit to that. Like you can train long enough that you are overfitting and it starts getting worse. But the problem is you can't detect that point just by looking at the loss curves. So we were originally using that as part of our heuristic on like sort of what the cutoff point is. We had to throw that away because it was a negative, like it was inversely correlated with model quality. So anyway, there's like, a dozen like little tricks like this that are just like, you really, I guess, have to build an intuition. You have to train a bunch of these models and see what actually works in practice.
Yeah, that's just another reason to just use OpenPipe and not have to deal with it. Wild. So we legitimately, what I'm hearing is we don't know why, but overfitting while training can be beneficial with LLMs specifically, but not other types of architectures.
And this is not like there's been some I haven't seen anyone like treat this in a paper. There has been some speculation. The people at Answer.ai, Jeremy Howard, anyone who's in the machine learning world sort of is familiar with him. Like he's done some observations and republished this exact same result basically. And he had anyway. There's a blog post there which I don't know if you have show notes, but we could probably look it up and try and throw them in there. So. And he has some speculations. Awesome. But I don't. Yeah, I have observed it empirically. But I haven't seen anyone who's come up with like something that's like super obvious. Like that's the reason why that's happening.
Interesting. Yeah, I'd love to follow this, and maybe by the time we publish the episode, we'll know more. If not, this is so cool to be like at the edge of like we just don't know. We're at one of those frontiers.
Oh, and that's just there's so much that we don't know. It's crazy. Like there's so much that's like, even if it's published, the publication kind of by the end just throws up its hands and is like, well, this is what we observed. Like, here's like 3 reasons why we think this might be happening. And then you also get a ton of that. Like a lot isn't even published. A lot of this is just like on like, there's a Reddit community called Local Llama where a bunch of people just like share what they learn. And then there's like these discords with like, Noose Research or Axolotl. There's like these just like groups of people online that are trying this stuff out and sharing like, hey, I noticed this. Did you notice this? And it's like it's that's the publication is like Discord, and no one. It's just so new that no one has taken the time to dig in and like really investigate a lot of these phenomena that we just observe empirically.
This is so cool. I wish I had a job where I could just do this all day, like investigate these phenomena specifically. I can sort of do that now, but I might get told off. I'm thrilled to announce that the Contagious Code podcast is now sponsored by Wix Studio. Digital marketers, this one's for you. I've got 30 seconds to tell you about Wix Studio, the web platform for agencies and enterprises. So here are a few things you can do in 30 seconds or less when you manage projects on Wix Studio. You can work in sync with your team on one canvas. You can reuse templates, widgets, and sections across your sites. You can create a client kit for seamless handovers. And you can leverage best-in-class SEO defaults across all your Wix sites. Time's up, but the list keeps going. Step into Wix Studio to see more. There's a link in the show notes. Thank you for bringing us into the sort of twilight zone of machine learning here, where it's so misunderstood and so magical. I think this is cool because there's lots of potential to understand things. We were talking about hyperparameters and overfitting, and how it's really nigh impossible to know the right combination of things without developing some intuition or just using OpenPipe. And we talked about some of them. We talked about epochs. Some people call them epics. I don't have a stance. I don't have a horse in this race. Can we also talk a little bit about the others? And again, the goal is to just give listeners an understanding of them, and also give listeners an appreciation for how OpenPipe takes a lot of this complexity away. What I'm talking about specifically is the learning rate. I've typically expressed this as 1e minus 4. And I'm sure there's a bunch of listeners who are where I am, right? They've read this on Medium, they've tried it, they've seen some results manually. But I think the vast majority of us who don't have a background in machine learning, I certainly don't, look at these numbers and go cool. What if I make it 1e minus 5? And then we just try a bunch of stuff like local llama on Reddit, but we don't really know what that means. What is the learning rate, and how does one optimize it?
Yeah, great question. So the learning rate is one of these hyperparameters we're talking about, and basically what you're affecting is okay. So usually this is explained with visuals. I'm going to do my best to explain it without because I don't have them. But
challenge.
But basically, when you are optimizing a neural network, the model is trying to learn sort of the parameterization, like the basically values of the weights that are most effective at producing whatever specific output you want, whatever you're training it to produce, right? So that's the goal. As you're going through this whole process, the model is trying to figure out, the process creating the model is trying to figure out what exact numbers can I plug into each of these, millions or billions of different slots that when all, in the final configuration, when I multiply them all together with a given input, will produce the output that the user is looking for. And the problem is that we don't know what the right values are there, right? Because if we knew what values to put in, then we would just put those ones in, and we wouldn't have to do any training, and we'd be done. And the thing is, there's no way to know, a priori, okay, what are the right values? And so that's exactly what the process of training or learning is it's trying to figure out iteratively, what values in each of these billions of slots are going to give me the best results at producing this. So while we don't know what the right actual values are, there is a very, very important thing which we do know, which is for the exact values that I have in this spot, in the sort of state of training I'm at right now, what are the results I'm producing, right? So we know we're producing results, and probably they're wrong results because we haven't finished training yet. And we know what the correct results are. We know what values we should be producing given this input. And so what you can do, given that information, is you can push the weights a little bit in the direction of towards producing the right output. Now, one thing you can do is you can push the weights all the way there and say okay, for this given input we have, if I change the weights by this huge amount, then I would be able to produce exactly the output that I want, right? And you could do that, and you would then have a model that for this exact input we took is going to produce this exact output we're looking for, which is great. Except probably the model is going to be completely useless for anything else because you're just optimizing it on this one example. And really what you want is you want a model that has a deeper understanding of this task and can work across all of them. And so if you're just every time you see an example, it's I'm pushing the model all the way towards producing that output, then you're just going to be ping-ponging between like vastly different weight configurations, but each one is only going to be good for like this for one specific input, or like maybe a small batch of inputs that you're training at once. So really what you want to do is you want to be finding a space in the weights that produces good values for all like, possible inputs, right? Or as many, the best possible value for best possible outputs for like every input that you're interested in. And so the way you do that is by, instead of just shoving the model all the way to like, okay, this is, set the weights so that this is the output, you're just moving it a little bit in that direction. And then hopefully as you're doing this, you're kind of getting to a place, since you're just moving it a little bit back and forth, hopefully like over time, you're kind of like settling down into sort of like this, usually you visualize it as kind of like this sort of bell curve you're trying to find the bottom of. And it's kind of like pushing it off of these peaks in the loss and towards the valleys in the loss, where for all of the inputs, you're able to produce like good valid outputs. The reason the reason you like the learning rate is important is because it kind of affects how quickly with each new example you get, how quickly you're moving. Because if you're just like, okay, I'm moving like super fast, then maybe instead of like settling into a valley, you're just like jumping across to like some other place that's like maybe even worse. Maybe it's even if it's better for like this specific example, maybe like overall, and very likely, in fact, overall, it's going to be like much worse on all the other examples. Whereas if you just move a tiny bit, you're more likely to be getting towards a place that's like, better for everything. So that's basically the intuition of what learning rate is affecting.
Okay, so it affects how drastically weights are adjusted towards a given output. This is so interesting because I find that it models the human experience very similarly, right? Because like if we learn something slowly but steadily, we actually understand it. And if it's like, look, I don't need to read the docs for the OpenPipe SDK, I'm just going to use it, and we make this big leap, we probably will have errors. Ideally not, because you've developed it with developer intuition. Maybe it's not the best example, but if we often run into things without reading the docs, we make mistakes. But if we learn slowly and practice, wow, that's really cool. Thank you. That was such a great explanation for the learning rate. Okay, so we have now fine-tuned the model because OpenPipe has set the right hyperparameters for us, including the right batch size and the epochs, as we talked about, learning rate, etc. And it's set this. We've got enough data curated by a large language model, and we hit the button, right? So we fine tune on OpenPipe. It runs through this process. The error goes down, and we have a model. We have it. It's working. What's the next step? Do we just naively now use? I know the answer to this, but I'm asking on behalf of listeners. Do we just use it? Do we expose this model straight away to our users, or is there some type of validation? If there is validation, what does that look like?
Yeah, totally. So I think this is something, I think a really important insight we had as well, which is, obviously, you shouldn't. I think maybe that's almost a leading question, and most people wouldn't just like say, okay, I got this model, I haven't even looked at the outputs, I'm just going to like put it in front of my users and hope for the best. So then the right question is like, how do you actually do that validation? Like, how do you build confidence that this is something that actually is going to provide a good experience? And I think the way I think about this is you really probably should have two different kinds of tests. And I call them, I don't know, I hope we develop, nomenclature around this. But it's kind of the equivalent of like unit tests versus integration tests on sort of traditional software development. It's a little bit different. I call them like inner loop tests versus outer loop tests in the concept of kind of deploying a machine learning model. But very similar, like intuition. So what I call inner loop tests are, you want to like be able to, just looking at the outputs from say your existing process and this new one, you want to have some kind of metric or some kind of test you can do to say like, okay, it seems like this looks plausible. And so there's multiple methods you can do to achieve that. One is, and the most common one is just like literally what people call a vibe check. Just like, hey, look at, a dozen of the outputs from your old system, look at a dozen of the outputs from the new one. Does it look plausible? And I think that's frankly like where the practice is at for many people deploying these models. Something that can be like a little bit more sophisticated is a process called LLM as judge, which is something that we implement. And by the way, I think like I'm not saying don't do the like look at the outputs. Like I think you definitely like you should always do that. It's like just helps you build intuition for if there is like things that are going wrong. Maybe you can quickly pick that up just by like looking at the cases that maybe it's messing up. But assuming that all looks good, then what we provide through OpenPipe, and a lot of our customers find value in, is these LLM as judge evaluations. And LLM as judge, that basically all that means is you take the input. So we have this concept of the training data. We already trained our model, and then, like I mentioned earlier, we're keeping out a test set that we're not using for training. So what we do for LLM as judge is, once we've trained the model, then we run inference. So we produce outputs for all these test set entries. You also have the outputs from your kind of like whatever your original process was using GPT-4 or whatever, with your prompt, which is what you use to train this. And so we're going to like let you define an evaluation and compare those side by side. And so you can put in the specific criteria on like, hey, for example, we have a user who they're doing summarization, and sort of the word count is very important to them. And so they want to make sure it's a high quality summary, but it's like, hey, this can't go over 50 words. So they'll put those instructions in their kind of like, their evaluation, say like, hey, make sure that the word count is under 50 or whatever, or is about 50. And then the way LLM as judge works is you take the input, right, that your original prompt, and then you say like, hey LLM, hey GPT-4, this is an input, and here are two different outputs. Here's response A, which is the one you got from the data set, and here's response B, which is the one from your fine-tuned model. And then, the way we do it is we give it a little bit of room for chain of thought. So that means we just ask it to explain, like, talk through the pros and cons of response 1 and response 2. And it'll kind of like write out, like a few sentences about like, well, response 1 was more concise, but also missed these key details. Anyway, it'll sort of like explain the pros and cons. And then finally we say, okay, which response was better, or are they about the same? Is it a tie? And so that's basically the concept is you ask it that. There's a bunch of tricks in this, things like, we have to randomize the order. You want to try and avoid using the exact same model as a judge that generated one of the outputs, because they tend to like their own outputs better, also like humans in that regard, probably. So anyway, there's a bunch of little tricks we have on how we do this, but the end result you get is you get a dashboard of these are, so say you grab 100 different examples from your test set and you run this on all of them. And then effectively what you get out of this is you get a number. It's like, hey, for between these two models, your model won 70% of the time, it tied 10% of the time, and it lost 20% of the time or something. And you can also click through. Those aren't just opaque numbers. We also actually in the app let you click through. You can see on a like test set by test set entry basis, hey, which one did it say was the winner? What was the reasoning it gave? And you can also, this helps you build intuition for like, do I actually trust this LLM as judge to be doing a good job on my task? And I think that's actually super important. Anyway, so that's all of that is sort of what I call the inner loop evaluation, which is, this is something you can run without actually sticking it in your app at all. This is something you can just like look at the outputs and be like, hey, do these seem plausible? Do these seem good? Now, I think outer loop evaluations are also super important. And that's the one you get when it's like, okay, let's actually stick this in my app. And maybe we're going to run an A/B test, right? Maybe, like 10% of our users or something like that, we're going to serve completions with one model and 90% the other, and like measure whatever metric we care about. So is it user satisfaction? Maybe in your case with the podcast search, is it like, do they actually click one of the results that came back, from this model? So you have to, that part is very, very application specific. It really depends on like what success looks like to you in your application. But I do think it's important that you at least think about that. Like, what does success look like? Is there any way I can measure that? And in many cases, maybe it's as simple as just like, user upvotes. Like, if it's a chat app, you get the little thumbs up, thumbs down. So there's different ways to gather this. But the point is, you probably should have some way of knowing in the actual context of where I'm using this, is this providing good value or not? And then measuring that with your old system versus your new one.
Awesome. Thank you. That was such a great detailed answer. I had no idea about this LLM as judge thing as well. And this sounds like it's a first-class citizen of OpenPipe, where you could just get it, build up an eval set and go like, hey, LLM, like, what do you think of this? That's built in? Oh my goodness, that's incredible. I sort of love how OpenPipe makes AI accessible to folks, but also uses AI on top of it. I haven't yet gotten that far with my models on OpenPipe outside of just like trying them. But in terms of like production grade evals, not yet. And the reason for this actually is because unfortunately my podcast search must always I don't think it can benefit that much from fine tuning. And the reason I say this is because it needs RAG. It needs real-time data. For example, if somebody goes right now on tage.as and asks like, hey, can we tell me about on the search, tell me about LLM as judge, right? There's no amount of fine tuning that will have I hope I'm wrong, but as far as I know, there's no amount of fine tuning that will have a model say, yes, Kyle Corbitt talked about this at this point in time on the podcast without RAG. I don't know that that's something I can encode. Yeah. So, and so maybe I can use fine-tuning and in fact, I do use fine-tuning just for the tonality of it all. But for the actual data points, that's still RAG-based. And I think this is an important distinction to make for listeners. A lot of folks go like, why would I fine-tune when I can just RAG? And it's often, and correct me if I'm wrong, but often the answer that I've been giving folks is fine-tuning is more for tone and sort of like verbosity and quality. It's not for real-time data. Is that accurate? Did I miss some nuances?
So no, that's right. I mean, I think it's broader than just tone. So it's absolutely true that it is not a replacement for RAG for actually bringing into the context the relevant information. But it's very complementary to that. It's just basically the fine tuning is like a replacement for the part where it's okay. Now you've built the context. Let's figure out what the actual output is. That's where you're going to get benefit from fine tuning. I think specifically in maybe a chat context or something like that, maybe tone is the main thing you'll get out of it. What we find is a lot of folks have somewhat more complex use cases where they're, it's like you're trying to extract a bunch of information in a specific format. We have one user, they've got 23 fields that they're trying to get out of. They have all these call transcripts and they're trying to extract literally 23 pieces of data in a structured format, like the dates of certain events, like certain balances, in your account, things like that. And fine tuning is incredibly helpful because GPT-4 gets it right 80% of the time, and then 20% of the time it just forgets a couple fields because it's a lot to keep track of, right? And with fine tuning, it's every single time they're getting exactly the data they want in exactly the format they want because the model's just been trained and so it becomes really, really good at doing that. So that's I think but generally speaking, yes, I think it's not about getting the data in, it's about getting really, really good at understanding this specific task and what is expected from me, if that makes sense.
Right, and also producing maybe more deterministic output. I have to imagine this begs a really interesting question. Is it possible through fine tuning to create a fork of or fine tune of Mistral 7b, for example, which is it's maybe not large because it's got 7 billion parameters. It's still a language model that outputs text. So natural language, English, and maybe other languages. Is it possible through fine-tuning to take something that just outputs natural language and turn it into a specialized fine-tune that only outputs valid JSON in a schema that I specify? Can fine-tuning accomplish that, or is that maybe too much?
So we can't guarantee it, not through fine-tuning alone. However, in practice, we have found that it can get pretty dang close. So there is this concept of which is completely independent from fine tuning, but this thing called constrained decoding. And constrained decoding can guarantee exactly what you're saying. Constrained decoding is basically a way of, as the LLM is generating text, forcing it to match a specific schema. And using this to match a specific JSON schema is a very common application. But all this to say, we've implemented constrained decoding now at this point because it was just like a nice to have. But we took a long time to do that because it just wasn't a problem in practice. Because even though fine tuning can't literally guarantee, like you're asking, it will be in this exact schema that I'm looking for, like it can, like, that's one of the easiest things for a fine-tuned model to learn is like, hey, there's this specific schema in every single one of my training examples. Like, these are the fields that I'm outputting. Like, that's just, I mean, that's super easy for a learning algorithm to figure out. And so in practice, like, yeah, that's like something that a big benefit you get from fine-tuning a model.
Okay. Wow. Constrained decoding. I never came across this term, but this is so
yeah,
interesting.
It's fast. I mean, it's a tangent. We can go that way if you want, but yes, there is so much. You know, if the level of abstraction you're looking at a LLM at is like, hey, I give it text, I get text out. I mean, that's already really cool. But if you just go like one level deeper and understand a little bit more about how it's actually producing this text, there's like so much more power in that. And I think like as an industry, we're still struggling a little bit with the right abstractions to expose that power to the end user to help it say like, hey, I want to like, you know, upvote this concept, basically, like, you know, make it more like there's all these ways you can basically, you know, affect the behavior beyond just like describing in text, this is what I want you to do. And again, I think we need to figure out the right abstractions so that the end user has that power. And, you know, constrained decoding is an example of this, where it's like you can force it to follow a specific schema, not through fine tuning or anything. You can make any model follow a specific schema, and a lot of people don't know about it because it's a little bit it's a little complex anyway. And also I think just because you know, the industry is not that mature and we don't have the right abstractions to make that like easy to expose to the user. But we'll get there for sure. Like you know, everybody's working on it.
I hope this podcast has a role to play there, because that's something we're planning is a series of lectures. So not guest panels, but just like me. We'll talk about all of this. So attention mechanisms and all of it, PEFT, etc. Okay. Speaking about making like what was it, constrained decoding, a big trend now with large language models is, I don't know if it's a big trend now, frankly, it's been a trend for a while, is tool use, right? So like Mistral just released, as of I think a month ago, Mixtral 8x22b, which is, as far as I know, the first open source pre-trained model that has support for tool use. Very, very cool. Function calling. I may be wrong here, but I think that's very cool that it's maybe, if not the first, one of the first that supports that. Is it possible to take Mistral 7b, which has no support for function calling, and then through fine tuning on OpenPipe or similar, give it the ability to call functions? If yes, what would that look like? Would it just be the prompt response pairs have instructions in there? This is something I've heard a lot, and I don't know the answer to. Yeah,
that's a great question, and the answer is yes. In fact, we launched with support for tool calls. You know, I guess 8 months ago or whenever we started. And yeah, fine tuning does a great job of that. You know, you basically just have to teach it like, hey, if you know, like it's the same as any other output you're training for, right? You just say like, hey, this is what a tool call looks like. You know, learn from the inputs and outputs, like when is it using tool calls, when isn't it? And they can pick that up really well. We've had great success. Lots of our users, they're using tool calls.
But tool calls are hidden, at least if you look at tool calls from something like ChatGPT, right? They're hidden behind beautiful UI and network requests, usually. Because they're calling a function in code, and what developers see is the function being called. They don't see the output from the large language model that is then decoded into something that invokes that function. They just see the function. So what would output look like from a large language model that does a tool call? Yeah,
so let's see. So when you're in, like, say, ChatGPT, if it's calling a tool, if it's you know, using the a web search, or if it's using its code interpreter or something like that, then what you see is kind of like the output of like, once it called that tool, then it's going to get the response from that tool, and then you'll see whatever came back. When you're using the OpenAI API, it works a little bit differently. Because the API they have doesn't have access to the tools. The way the tool calls work from the API perspective is, when you're sending a request into the API, you actually tell like, hey, this is the list of tools that you have available, or rather that I, as like the end user, have available that you can use. And so then what the OpenAI API, what GPT-4, whatever does when it gets that list of tools, it's like, okay, with this input, this list of tools, all right, yes, I think the output from this tool X is probably going to help me answer this question. So it'll come back. But the response you actually get, it's not the output from the tool because it itself doesn't have access to the tool. It's kind of like sandboxed. What you get back from the API is basically saying like, hey, this is the tool I want to call, and these are the arguments I think we should pass it. And so then you, as the developer, are responsible for calling that tool, like actually calling whatever function it is, getting the response back from this external system or whatever function you have in your code. And then if you, and honestly, that's like usually the step where in practice, I see most people finish. They get the response back and then they just like show that response to the user. But if you do want to have OpenAI sort of summarize or use that tool in like an additional chain, then what you have to do is you have to send a new request to OpenAI with all the context from before, including the like, hey, these are the tools and everything. And then you actually send a special message called a tool message as kind of the final message to say, okay, I called the tool that you told me I should call. This is what the output was. Now go ahead and generate whatever the next step is.
I want to. Sorry to interrupt you. I want to push back a little bit on this, and partly because I'm actually working on a framework. Think Next.js, but for like tool calling and agent workflows. But and this is something that I still don't understand working on this thing, which is the OpenAI API, when there's a tool call, will return you JSON, right? It returns you JSON where the user is the assistant and the type of message is a tool call. And then, sure, it contains the name of the tool and the parameters, as you mentioned. But my question from the machine learning side is, how does OpenAI generate this JSON? Because it has to get text out from a large language model and then wrap that in some JSON for the developer, and then serve that across the API. So could it be that the large language model literally just puts out like a sentence, like I want to call this tool, and then OpenAI then does a big regular expression match or parses that sentence somehow and then generates JSON? I guess this is the output from the LLM, the plain text output from the LLM for a tool call. This is where I'm confused. Like, what does that look like, and how does then OpenAI know to wrap it in that JSON object?
Yeah, that is a great question. So again, this is where if we could just go like one level deeper,
exactly,
and I think it can be really helpful in building a mental model for what's actually happening. So the important thing, and it sounds like you already have this intuition, is like from sort of the LLM level, from the model itself, the only thing that's ever going into it is, this is a little oversimplified, but for this purpose, it is true. The only thing going into it is just like a string of text. And then the only thing coming out of it is another string of text. That's all it does. So it doesn't, it can't format in a special way. And so then the question becomes, okay, if all we're getting out is a string of text and we want it to be able to call tools, like how do we combine those? And so the way they've done it in practice is conceptually very similar to what you described, where it was like, hey, the model's saying like, I want to call this tool, here is the tool name, and then it just like prints out, here are the parameters we should call this tool with. It's a little bit more what's the word? I guess like specific or concrete than that, in the sense that instead of literally saying like I want to call this tool, there's when they're fine tuning the model, because OpenAI also does fine tuning internally before they release these models. They don't just release kind of like the pre-trained thing. And when they're fine tuning it and teaching it how to use tools, they have a special token. And a token is just it's basically like a special string of text. And the meaning of this token is just like, hey, I want to call a tool call, right? And so it's like, the way they're represented in text is like usually they'll have like an XML like tag, which is like, start tool call or something like that. And so from the model's perspective, it's just exporting like this very, very specific, you can think of it as just like a short string, right? That indicates I want to call a tool. And so it, if you see it serialized out, then maybe it would just look like an XML tag that's just like start tool call or something like that. And then it'll output the name of the actual tool call. And then you'll have like another tag that's basically like, start tool call arguments or something like that. And then it'll output the sort of like string of what the arguments should be. And that string is literally, it's just like outputting a JSON string. And by the way, I don't know if you've seen this yet or not, but there's no guarantee that they're not using the constrained decoding stuff that I was, or at least as of a couple of months ago, they weren't using constrained decoding, which I described earlier. So those arguments, you actually do have to like check that it's valid JSON, because I've gotten cases where it's not, especially if the sort of like tool call is more complex, and maybe you have nested fields or something like that. Like sometimes it just like messes up and doesn't return valid JSON for the arguments. So something to watch out for with your with your library.
That's so cool. Yeah, that's why that's probably why the Vercel AI SDK forces users to use Zod, which is the schema validation library. Cool.
Totally. So yeah, I think that is, and I'm sure at some point they will do the constrained decoding thing, because everyone else does at this point, and it's just the right thing to do. But anyway, But yeah, that's kind of like how it works. And then basically at the API layer, so after OpenAI gets that string out of the model, then they're going to just like you said, do a regex, right? And they're going to look for, okay, do we have this special like start tool call token? And if so, then they're going to do a little bit of parsing. They're going to extract, the tool call name, and they're going to extract the arguments, and they'll give it to you in that shape you're looking for, even though it came out as just like a string of text.
That's so cool. This is actually my this is a project I've been working on locally. And I didn't know it was possible. I literally had Mistral 7b here in my fine-tuned Jupyter notebook, and I was trying to teach it tool calling, and I just didn't know how. So I first of all, thank you for telling me that it's possible, and also for describing the ways I can go about it through this like XML-like token. And through constrained decoding. I've never even come across this term ever. So I'm excited. I have so much homework. Thank you so much.
Awesome.
So, okay.
By the way, if you're trying to make your own tool calling model, a great, like sort of prior art you can look at. There's several out there, but I'd say the most popular and best done one is one from a company called Noose Research. And there's a model they have called Hermes 2 Pro that is trained with function calling, and they sort of you can sort of look at the serialization schema they use to define the functions that they're using to train on, and that might help make this discussion a little bit more concrete.
Awesome, perfect. Noose Research, you said, like the knot that people use for.
It's Nous, and I have no idea where that word came from, but yeah.
Fantastic. We'll put a link to all of this in the show notes. Awesome. Okay, so we have we've evaled in our life cycle of fine-tune. Now that we've talked about that, OpenPipe takes a lot of this work away. We've done some evals. We've used LLM as judge, and it looks good. We're ready to put it into production. Now, with OpenPipe, as far as I know, it's just a matter of changing the configuration parameter in your code, right? You say just talk to this model instead. If we're not using OpenPipe, and again, we just want to capture like the complexity that OpenPipe saves us from. If we fine-tuned locally on some like Jupyter Notebook thing, we would have like a gguf file or similar, right? We'd have like this model, this 80 gigabyte or at least document here on our computer. What do we do with that? Like, how do we host this thing? Now there's tools like Ollama, which you could probably run in the cloud, and Ollama's, for those listening, it's like Docker, but for machine learning models. I think it's quite cool. But maybe we could speak to some of the work that OpenPipe offloads in terms of actually hosting a model and then doing inference over like an HTTP API.
Yeah. So yeah, there are definitely good open source tools out there. I mean, one very concrete reason, by the way, why I don't recommend people go this route unless you really have to, and usually there's not a good reason, is because, like you were saying, these models have huge weights, and you're going to have to load that on a GPU if you want to get decent inference speed. I mean, if you want to have basically more than one user able to use it at once, and putting that on GPU in the cloud is quite expensive. Several $1,000s like a month is sort of like the minimum I see, even for like a relatively low power GPU like an A10. So an A10 on AWS, I think it's like $2,200 a month or something. So usually it's not like you really do want to outsource that if you can, purely from cost reasons. And then with one, you sort of like have a max throughput you can get. But yeah, you can definitely do it. So the library I would recommend if you're actually trying to serve in production is actually not Ollama, but it's another library called VLLM, which is really optimized. So Ollama is optimized for running kind of on CPU in sort of a single user environment. It does have GPU support, like llama.cpp, which it wraps can run on GPUs, but it's not that efficient. There's a lot of sort of like optimizations it leaves on the table. So there is this other open source library that's really, really good called VLLM, and that one is really made for kind of like, hey, I'm running this in the cloud, I'm exposing an API endpoint. So that's the direction I would go if you're trying to do this. The other problem you run into is kind of related to our earlier conversation about like how are you actually like creating parsing out the tool calls. When you create this model, like there has to be there's this step of, remember, all the model takes in is like a string, right? And all it puts out is a string. And really what your model and you probably don't want to write your own parsing code. I guess it depends on how complex the task you're trying to do. Maybe in some cases that's fine, and you can just write it so it's like I'm sending a string, I'm getting a string back. And if so, then there's not that much extra work. But if you have written your app already sort of with the expectations of like the OpenAI API, and that's kind of the shape that you're expecting, then it is actually substantial extra work to like basically figure out how am I serializing it? What I have is like this list of messages and these tool calls, and I have to like figure out how to get that into a string, right, that I can send to the model. And then what the model is going to send me back is a string. And what I really want, what my code is expecting, is something that's in the shape of like, an OpenAI assistant message. So so that's just like extra work you've got to figure out how to do. And it's possible to do, but you're going to end up writing your own custom code and your own custom templating to figure out how to kind of like serialize it on the front end and deserialize it on the back end. And if you want to do streaming, all of this gets like way more complex because you have to be like serializing on the fly and do like partial deserialization of kind of like the response to figure out what the shape is and get the chunks. Anyway, so that's sort of where I think a lot of the complexity comes in, apart from just like actually getting a GPU and getting the weights on it and everything.
Mm-hmm. And how does OpenPipe do it? Do you all have a bunch of GPUs that you host fine-tunes on and just bear the cost because venture capital money?
So we do have a bunch of GPUs. We are, we don't want to be playing the game of just like burning VC money to serve our users. So we're very thoughtful about the way we serve. And one of the big advantages we have over just running it yourself is because we have a bunch of users, we can actually multiplex the models from many different users on one GPU. And the reason that's possible, and this is something we actually, I don't know, maybe this is something that should have come up earlier in the conversation, I don't know, but when you're actually doing the fine tuning, there's different techniques you can use. Sort of the default one is doing what's called a full fine tune, and that's where, as you're figuring out, hey, what weights do I want to change? You are, every single weight anywhere in the model, you can kind of move a little bit, and you can optimize the whole model. So that's one technique, and that works well. The one we use is a different technique, which is called LoRa. And what LoRa does is the original model you're starting with, so like your Mistral 7B or Llama 3.8B or whatever you're using, it's actually, you're not changing it at all. That model is staying exactly the same through the whole training process. And instead what you're doing is you're inserting at, say like 28, 30 different points in the model, these tiny extra layers that have many fewer parameters than kind of like the whole model. For the ones we do, they have about 2%, or rather 2% of the full model weight are these kind of like small layers we're inserting versus the other 98% is kind of the base. And when you're running the fine tuning, we're actually only adapting the weights in those like very thin layers that we're sticking in like at all these different places. We're not changing the weights at all of the base model. There are pros and cons to this. A con is there is only so far you can affect the model's behavior if all you're doing is changing these 2% of the weights. Now, it actually takes you a lot further than you would think because the people who developed this were really smart and very strategic in like the exact configuration and where you actually stick these weights. And so they can punch, far above their weight, I guess pun intended maybe. And so you can push the model very, very far. But there's a theoretical upper bound to like how much you can affect model behavior if 98% of it is just staying the same. So that's one of the cons. One of the pros is actually like very often you want that guardrail. Like very often you don't want to, because if you're doing a full fine tune, you can do anything and you can totally very easily like destroy the capabilities of the base model. With these LoRa's, like it's much harder to sort of get what in machine learning is called catastrophic forgetting, which is the concept that as you're training or continuing to fine tune on a specific data set, like it kind of like gets much worse at everything kind of outside of that data set. which is bad because when you're actually running inference, if there's anything like a little bit out of bounds, you want it to still like do a good job with that. So a pro of LoRa is, usually most of them or almost all of the abilities of the base model stay present. So those are kind of pros and cons on the training side, but on the inference side, there are huge pros to LoRa's. And the reason why is because if you've got 1,000 LoRa's, but they all have the same base model, well, you can just load that base model one time on a GPU, and then as inference requests come in, so our LoRa's like in sort of the actual size, say for a Llama 3 8B, like each of our LoRa's is only like 50 megabytes, which is like big for a file, but a lot less big than,
an 80 gigabyte
27
model.
gigabytes or whatever it is for the whole base model. And so we can like move these things around really fast on the fly. So we've got all these sitting in S3, and then as soon as a request comes in, we're going to, on the fly, grab the relevant LoRa for that fine-tuned model. We're going to load it into system memory. We're going to load it into GPU memory. And that entire process, like from end to end, from when we get the request and when we have the weight sitting in GPU memory, is about 0.8 seconds. So you have extra latency. You have that extra 0.8 seconds it takes to get the weights in. But the thing is, because these are so small, we actually have it configured so we can have the weights on every single GPU. We can have up to like 300 weights, 300 different LoRa's in GPU memory at the same time. And if you start talking about system memory, like the off GPU, just like the normal RAM you've got, we can have up to 1,000 just sitting right there. And the latency from system memory to GPU memory for something this small is like 50 milliseconds. So anyway, the point is, the overhead really is not significant, especially if you're calling your model more than once, like every hour or so. It's like probably going to be sitting in either system memory or GPU memory, and so the latency overhead is insignificant. And what that lets us do is it lets us, since we're multiplexing all these, we can give you way better prices than you would if you were just running it on your own GPU, because we're sharing that across all of our different users, and basically just have like one scaled deployment per base model, if that makes sense.
This makes so much sense, and this is a whole different sort of compelling business case for OpenPipe that I had not seen until just now. For those listening, by the way, who are confused by the LoRa term, it's low rank adaptation, I believe, which is exactly as you defined it, but I just want to give them the expansion of that. Incredible. That's so cool. I love it. I want to start wrapping up and ask you a couple questions. One about business and the other one about sort of more entrepreneurial spirit stuff. Let's start with a business question. I want to ask you about the future of OpenPipe, because throughout our discussion today, you've mentioned multiple times where AI is not just something that OpenPipe facilitates, but is also a first-class citizen of OpenPipe itself. From like LLM as a judge to curating the testing data sets, the training data sets, excuse me, and all of this. At some point, this sounds like OpenPipe could be a real good application for agentic workflows, AI agents. This is the word now that's in the zeitgeist, right? But if I think about it, there's a number of touch points that I still have as a user, as a human user for OpenPipe, that I could just replace myself with an AI agent. Where, for example, recognizing when I have enough data to then curating the data is already done, but starting the fine tune, I still do that. And then once the fine tune is finished, evaluating this. Could we maybe speak to making the entire thing fully automatic, right? You just like log in with OpenPipe, switch out your SDK and code, and then one day you wake up and it's like, hey, just so you know, there's already a fine tune. We've evaluated it and we've actually switched you over because like it's good. Is that, how far away from reality is that workflow?
Yeah, that is a great question. So yes, that is absolutely the vision. Like we want to get to the place where we can do that for you. The thing is, like, we have to be really, really confident, right? That we're like actually like that our evaluations are highly correlated with what you want before we're going to do anything automatically. So I think probably where we'll get to first is it'll be okay, we fine-tuned a model for you. Here are the eval results. Like, hit this button to move it over. I think we'll probably sit there for a while before we turn on kind of like the auto optimization. But yes, no, I think absolutely getting that auto optimization running is the long-term goal. And like where we want to get, and by the way, I think we can go in two directions with this. One is, obviously we're making it faster and cheaper. I think there's also a ton of room to expand in the other direction. And this is actually also kind of, I was just reminded of this because you brought up agentic workflows. We have found that agentic workflows, and this is not a unique finding on our part, but we've found that agentic workflows can vastly improve the quality of the response, even without any fine tuning at all, just through prompting. Basically, by you start by calling GPT-4 and say, hey, this is the output, and then you like run some basically like tests and let it reprompt itself and think about the output and come to a higher quality output. So I think that's another direction we're interested in going, is like, hey, let's start by letting you kind of like hit our endpoints, and it's going to increase latency because we're doing all this stuff in the background, but you're going to get like a super high quality output. Run that in production for a few days, and yeah, it's kind of slow, but you're getting really, really high quality. And then automatically over time, this is going to get faster and faster and faster as we're distilling this down, as we're starting to fine tune models based on those really high quality outputs we're getting from that agentic workflow. And then over time, as your usage keeps growing, we're fine tuning smaller and smaller models for you. Your cost per call keeps going down while your latency keeps going down, and your evals are staying the same or increasing. That's definitely where we're going.
Incredible. I'm so happy I called that, because it seems almost like a no-brainer. I'm very excited for this. I also, full disclosure, a lot of the podcast. So we started with once a week. We used to ship every Monday, but then we everything's run with AI except this. So I'm here. This is actually me, and this is I hope actually you, and we're talking as human beings. But everything outside of this is fully automated with agentic workflows. So from the moment you book the cal.com, we have a discussion guideline outline. This is all just generated with a large language model attached to the calendar event.
I would love to hear what inputs you have. How you do that. That's very interesting to me.
Yeah, and it's just it's an agentic workflow. Once we stop recording, then show notes and processing, all of this is just completely automatic. The only manual touch points are the face-to-face discussions and the actual upload, because I don't know how to the final assets are like 12 gigabytes, and I don't yet know how to programmatically upload that to YouTube. We'll maybe find a way, but there are at this point two definitively human touch points, and as you can imagine, Kyle, it gets very expensive when running on OpenAI, and this is my case also for OpenPipe, and this is my question earlier about, can I fine tune a really, really cheap model to use just my specific tools, because this is not going to be used by more than one person. It's my podcast and it's my workflow. I could run this on localhost. I could run this on ngrok, on my single GPU, whatever, right? And so if I can bring my costs from OpenAI to what they are now, to virtually zero or whatever I would pay on OpenPipe, that's tremendous. So anyway, I'm happy to show you that workflow. And it's not just me. There's a bunch of folks working at least in the web space on this. People like David Khurshid, Sunil Pai. Everyone's trying to create the next JS, but for agents. And so it's a fun time. Okay, I wanted to ask you, so this is probably the last question. I wanted to ask you about something I've been asking everyone. So we're in the middle of founder series, co-founder series, and CEO series. And I've asked this of everybody so far. And it's quite cool because everyone's had maybe a different answer, but we're trying to glean commonalities. And the context for this is, sitting in a room with some friends, and many of them first time, maybe not first time, but I would say non-professional co-founders and CEOs. And by professional, I mean somebody that the board appoints to be the CEO who's done it before. A lot of these folks are just really great engineers, hackers, technical founders who they're the CEO because they started it. And we were talking about how it's so different, how they didn't know what to expect, and how it may be nice to have some type of document, a handbook, a charter to go pay attention to this or pay attention to that. On the web, we have documents like the HTML living standard and CSS, and a lot of language specifications are just this word means this thing and use this for that. Even with fine tuning, we have the hyperparameters that just tell you things, right? The job of a technical founder is often ambiguous and unspecified. You have to improvise on the spot. And so, we asked a number of them. We asked Guillermo Rauch, we asked Matt Bielman from Netlify, we asked a bunch of folks, what do they wish would be in such a document should it exist? With their experience, what would they share with fellow technical founders and maybe CEOs? And they had some great things to say. For example, Bielman said, the most important thing is adaptability, because everything changes very rapidly and you've got to be able to do that. Guillermo Rauch said using the product that you're building is the ultimate game changer, because you develop developer empathy. and it helps you create things people actually want. Brandon Bayer from Flight Control, and also Glauber Costa from Terzo said that engineering's hard. It's okay. We're solving complex and ambitious problems, but really the harder and hardest thing is positioning and messaging. Marketing is infinitely harder than the engineering, is what they said. So with all of this, should a document like this exist, what would you contribute? What is something from your experience that you've gone, oh my gosh, I wish someone told me this. I should maybe tell someone this just so that they're not caught off guard. What would you add, or what would you hope exists in such a document?
Yeah, great question. I think, first of all, it'd be hard to have such a document that was both comprehensive and useful, because the thing, and this gets back to one of the answers you gave, which was you have to be adaptable. Like the thing is, like, there are so many different challenges that you face on a day-to-day basis that, like, learning the answers to all of them ahead of time is both not feasible and, like, not useful, because, like, I don't, if there's some problem I'm going to face 6 months from now, like, I should not be spending any time at all right now thinking about it, because I've got plenty of problems tomorrow that, I've got to bust through before I get to that one. So I'm not sure that, like, the right framing is, or at least, it maybe a reference manual that, like, when you get to this, like, when you have this problem, open envelope A type of thing is framing. I would say at the stage that we're at, or that we've been going through recently, a few things are, you should be like, and this is very specific to technical founders. I don't think this is the case for everyone, but for me, certainly, and for technical founders listening to this, like, you should be spending way more time than you are talking to users, and, like, actually just, like, out in the world, and not thinking just about your product. And that does not come naturally to me. Like, we've got this great roadmap that I'm extremely excited about on the product side that I think is going to provide so much more value than we even have today. But when I take a step back, it's like, the value we provide today is significant. It's, like, very large, and, like, my time is probably better spent sort of evangelizing that and explaining to people, hey, this is how you can use this today. And yes, tomorrow we're going to be even better, and we're going to solve more problems for you, and it's going to be cleaner and everything. But, like, getting people on it today and providing that value to people today is going to, like, it'll not only, like, be good for the business, but it'll actually help us make that next version I have in my mind even better, because we'll have more feedback from actual users on the current version, which really helps us prioritize that stuff. So I think that's the high level thing I would say is, like, spend more time talking to users, spend more time pushing the product, spend more time selling the product. You'd be surprised how much you can sell before you even have a product. We signed our first big contract before we had any, like, before literally we had any, like, productized fine tuning. Like, we were literally just running our own Jupyter notebooks. Like, wow. The user would upload their data set and it would say, like, fine tuning, and, like, I would get a text message, and I would go and, like, in my Jupyter notebook, go and, like, manually download the file and, like, run it, and then, like, manually upload the assets, and then, like, flip the bit in our web UI saying, like, your model's ready now. I mean, but it's because we were selling it before we even really had a product. So anyway, I think just, like, talking to users, trying to get their feedback, trying to get them to actually get on your platform as early as possible is going to help you, move faster and be more successful.
Fantastic. Yeah, this is, I feel like that's kind of what you're doing now, talking to a user, aka me. And this is also, this worked exceptionally well for a unicorn today called Hasura. Hasura is a GraphQL API on Postgres, where, dude, I remember, like, 7-ish years ago, I was at a conference in Berlin, and they just, the founders were just there, like, walking around and, like, borderline harassing people. I say this positively. Like, they just like, hey, do you have 2 minutes? I want to show you my thing, and tell me if it's good, and it seems to work. I would add some nuance there based on what Bielman from Netlify, the founder of Netlify, said. He was like, there's a right time to listen, because if you're solving a problem that nobody can comprehend, they're going to tell you it's a bad idea and don't do it. And he said, yes, everyone told him not to start Netlify until he showed them the value or the initial prototypes, and then they went, oh, this is good. And kind of like you were talking about with your users uploading their data sets and saying fine tune. That's when you sort of, and I don't know if I'm, like, reading too much into what you're saying, but that's the moment where you went, like, okay, this is something to productize now that we've talked to people and established this need. Fantastic. Awesome. One final question. I promise this is the last one. You mentioned in your introduction to yourself, you said, I already knew I wanted to be a founder out of college. There's a ton of folks who, with this mindset, who maybe even just graduate college and they go, like, I don't want to work for somebody else. I want to do my own thing.
Sure.
has that served you well? What would you say to these people or I guess, what would you say to yourself many years ago?
Oh yeah. Let's see. So first of all, I think maybe there's a little bit of nuance to my answer. I would only recommend this to someone who already feels that way strongly. I've known a lot of founders. I worked at YC for 4 years and just like have a lot in my network. And I think if you want to start a company because it's just like, either I want to get rich or it's just like a cool thing to do now because it didn't used to be that cool. Now it's more cool. I think the lows are so low that if you're really relying on extrinsic motivation, it's gonna chew you up and spit you out. So you really have to, like, the only people I recommend actually doing this is like if you just have like a deep internal need. It's like, no, I want to do this. Like I want to leave my mark on the world and build something that's mine. And so anyway, that's my first caveat. But then I would say, if that does describe you, if you're like, no, that's what I want, that's what gets me excited, then yeah, you should do it. Because the lows, like I said, are really low, but like you cannot. The highs are really, really high, and not high in the sense it's like, it's just that feeling of like, I built this. Like this is something that I can point to and say like, I made that in the world. I created something that people love, and that is for someone who is motivated by that. There's no other way to get that feeling. At least not that I've found. And I've done. I've been relatively successful, I would say, in non-founder roles as well. Like I led a significant team at YC that increased our applications by 40%. I mean, had quite a large impact on the business, and I was really proud of that, and that was fun, and those were fantastic. And I don't want to like talk bad about that experience at all. I loved YC. I loved the people I worked with. I think everyone was like very purely motivated by helping founders, but it wasn't the same. I mean, it was I was incrementally helping the existing business, and I did my best at that, but you don't get that same feeling of accomplishment in any other way that I found. So if that describes you, then I think you should do it. I don't think you need to wait for anyone's permission. I think you should just go start building stuff and see how far you can get.
Well, on that note, I can't think of a better note to end this on, especially as a user who, indeed, you said there's a sense of the high is the sense of accomplishment and pride in that I made this thing that other people love or can love. And indeed, as somebody who uses OpenPipe and genuinely loves OpenPipe, I think this is a great place to leave it. So, Kyle, listen, it's I don't take it lightly that you'd come here and share all of this with us and really the detail. I think your love for your craft and your competence in it is undoubtable. And the fact that you'd share all of that, all of the complexity that OpenPipe saves us from, and then going into things like LoRa and the hosting mechanisms and LLM as a judge and all of it, on behalf of myself and all of the listeners, thank you so much for coming on the podcast and sharing that with us today.
Absolutely. It's been a real pleasure. Really great talking to you.
Thank you.
Thank you for joining my discussion with Kyle Corbitt. I hope you enjoyed it as much as I did, and I truly did enjoy this one, significantly. I learned so much about machine learning, about Python, about fine-tuning, and I feel confident to create my own fine-tunes. In fact, I feel so confident in creating my own fine-tunes that I don't mind using OpenPipe because I know how it's built. If you're learning from and or enjoying this content, then if you're listening on Apple or Spotify, if you leave up to a 5-star review, that'd be super helpful. If you're watching on YouTube, if you'd subscribe to the channel and like the video, that would also be a great no-cost way to support it. Of course, if you want to share any of this on social media, be my guest. I would actually love that. If you have ideas for topics to cover, guests to have, leave a comment on YouTube. I read all those comments and I just really want to serve you. For now, thanks so much for sticking around. Thank you for being a part of this podcast. And most importantly, thank you for your interest in engineering.